Good morning or good afternoon. Today we're back and we're going to talk about angles and polygons. So what we've been talking about has been quadrilaterals, and a quadrilateral is just a shape with four sides. So even that right there is a quadrilateral. That's, a square is a quadrilateral, a trapezoid is a quadrilateral. All those shapes are quadrilaterals. What we're going to get into today is different types of polygons. What if a shape has more than four sides? So when we talk about all these different polygons, we're going to get into pentagons, hexagons, septagons. What's important to note is that we're going to keep in the realm of regular polygons. So, like I said, there's so many, there were all those different quadrilaterals. There's so many different pentagons. So, that's a pentagon that has five sides. That's a pentagon that has five sides. That has 1, 2, 3, 4. That has five. There's so many different pentagons to draw. So we're going to keep in the realm of regular polygons. And a regular polygon just means that it's equilateral and equiangular. That word isn't just for triangles. So today, as we look at different shapes, we know a quadrilateral adds up to 360. We're going to look at different shapes today. Keep in mind that they're going to be equilateral and equiangular, so they're going to have congruent sides and angles. And that's going to keep it a lot more simple as we're drawing these shapes today and discussing them. So a lot of these things you already know. For example, a triangle, sometimes known as a trigon, has three sides. That's something that you already know. A triangle has three sides. If I were going to draw a picture of it, I would want to draw an equilateral, equiangular, so I'm going to try to do my best. And then I can go ahead and put ticks in there because it's equilateral. I can go ahead and put arcs in there because it's equiangular. And then a lot of these questions you already know, what's the sum of the interior angles? Well, what does the inside of a triangle add up to? 180. So if we said what's just 1? Well, 180 divided by 3. You hopefully remember some of this stuff. That's just 60 degrees. That was equiangular. They were all 60. Now the exterior, if you walk all the way around, pretty much any building, doesn't matter the shape. The outside will always be 360 degrees. Think about it full circle. Those angles will always add up to 360. So if I wanted to know what's one exterior angle, well, a triangle has three sides, three angles. So 360 divided by 3 would make that 120 degrees. So that's not anything really new. That's just a triangle or a trigon is what some people call them. Now, we've been talking about quadrilaterals. Quadrilaterals, have four sides. And if we were going to draw a regular quadrilateral, think about it. What's the quadrilateral that has all congruent sides and all congruent angles? And that's a square. So I'm going to put ticks all the way around. But we know specifically with a square that all the corners are 90 as well. So I'm not going to draw arcs. I'm going to go ahead and put those boxes in there. If I asked you, what does a quadrilateral add up to? Well, a quadrilateral would add up to 360 degrees. So what would be one interior angle? Well, that's where 90 comes from. 360 divided by 4 is 90 degrees, where that box comes from. Now, if we go all the way around a square, well, the exterior is also going to be 360. And if I asked you to find one exterior, well, 360 divided by 4 is once again 90 degrees. Now, those are shapes that you know. Those are shapes that you're familiar with. What we're going to get into now is some more polygons, some more regular polygons. So, pentagon. If you think about it, a pentagon has, maybe you know, maybe not, a pentagon has five sides. So if I were going to draw a pentagon, the easiest way to draw it is to kind of draw an upside down, think of the trapezoid with a smaller base and then a half triangle on top, so connect. So think draw a trapezoid on the bottom and then draw a triangle on top. And it's okay that it's not going to be perfect. I use Notability, this feature on the iPad. It will make it perfect for me, which is really nice and neat. Okay, I'm going to go ahead and put ticks all the way around. And then I'm going to go ahead and put arcs because we're talking about regular polygons. So equilateral, equiangular. Okay, now the sum of the interior angles in a triangle was 180. And a quadrilateral, it's 360. So as we can see, this number is going up. So I'm going to go ahead and tell you for a pentagon, the interior angles would add up to 540 degrees. So a pentagon would add up to 540 degrees. So if we said, let's just find one interior angle, well, I would take 540 and divide it by 5. So 540 divided by 5 would be 108 degrees. Exterior all the way around is still going to be 360. And then to find one exterior, 360 divided by 5, well, that would be 72 degrees. So as we notice, like this number is getting bigger. So the interior angles are getting bigger. So each interior angle is increasing, right? The exterior angles are staying the same. Therefore, each exterior angle is decreasing, is getting a little bit smaller. So let's continue to look and see if we can figure out a pattern here. So if I go from 180 to 360, well, that's 180 times 2. That's 180 times 360, right? If I add 180 again, so let's try, like 360 was 180 times 2. Let's see, go to your calculator and figure out what's 180 times 3. Well, 180 times 3 is 540. So there's a bit of a pattern there. So like 1 times 180 is 180. 2 times 180 was 360. 3 times 180 is 540. So pretty much this is increasing by 180 every single time, and the 360 has been staying the same. So if I talk about a hexagon, well, a hexagon has 6 sides. So hexa means 6. The easiest way to draw it is to draw that trapezoid and then connect with the trapezoid on top. So draw like a trapezoid on the bottom, draw a trapezoid on the top, and then that's the way to connect it. Some people will do like a V and a V and then connect them. Either way, it should have 6 sides. Okay, because I'm talking about regular hexagons, so we have a trapezoid on the top and a trapezoid on the bottom, essentially. I'm going to go ahead and put ticks in there. I'm going to put some arcs in there. Okay, so we said each one increases by 180. So I can do 4 times 180, or I can do 540 plus 180. So 540 plus 180 would be 720 degrees. If we just wanted to find one, then I would do 720. So it's a hexagon, 6 sides. My interior is increasing. So that was like 4 times 180. So now I can take that number and divide by 6. And that's going to tell me how many there are of 1. So 720 divided by 6, that'd be 120. The exterior has been staying the same. So like all the way around is 360. And so then to just find one exterior, I would do 360 divided by 6, which is 60 degrees. So hopefully you're starting to see some patterns here, and we're going to try to figure out if this pattern works for all of them. So notice like every time it increases by 180, that's going up, that's staying the same, and then that's decreasing right there. Okay, now heptagons are sometimes called septagons. That means 7. So hepta 7, septa 7. I'm really, really horrible at drawing these, by the way. So like it's pretty much like a trapezoid, and then it goes in a little bit, and then it goes in even more. So you can like Google it if you want. Like I said, I'm really bad at drawing these. That's okay. We don't have to be artists, but it's pretty much like a trapezoid. It goes in, and then it goes in a little bit more and a little bit more. We're going to see if this will auto-correct it for me. It might not. Sort of. We're going to roll with it, and it's okay if our picture is not perfect because I'm just going to put some ticks and some arcs on there. If you Google regular, so be careful, Google like regular heptagon or septagon, you'll see what it looks like. It's kind of funky looking. So notice every single time it's gone up by 180. So I had 4 times 180. Well, I can just add 180, or I could do 5 times 180. And that's going to be 900 degrees. And a lot of this is just number crunching. So it's increasing by 180 every single time. If I just want to find one of these interior angles, well, I'm going to take the sum, 900, and divide it by how many angles there are, which is 7. And sometimes you're going to get a decimal on this one specifically. That's okay. So 900 divided by 7 would be 128.5. So we're going to say 128.6 degrees. Remember, all the way around has always been, every single time has been 360. And so to just find one exterior, I'm going to do 360 divided by 7. I'm going to get a decimal again. That's okay. That decimal is 51.4 degrees. So notice we've kind of had some patterns. We've seen things increase. We've seen some things decrease. So octagon, you're probably familiar with. An octagon has 8 sides. The easiest way to draw an octagon is to take like 2 trapezoids and then connect them like that. So think like trapezoid. It's like trapezoid, trapezoid, and then connect them with straight lines. I like to do what's like the square method, which is where I essentially draw a square and I cut the corners off and then I connect those corners. Like that's also an octagon. So I can pretty much draw a square and then like connect the corners. So that works really, really well as well. And it's okay if they're not the greatest. An octagon is like a stop sign. Think of it that way. And our pictures don't have to be perfect. I'm going to go ahead and put ticks on there and arcs, and that just kind of is a geometry way of saying it all worked out, it's all regular, everything's okay. Now, I want you to take a minute, and we'll pick up in the next video. I want you to see if you can figure out these numbers from here, and then see if you can find any other pattern. And we'll check back in the next video to see if you got your numbers correct and if you found that pattern.